Okay, so we try, no? So we are on, what we are on waves, no? Mechanical waves and sound waves, no? And basically, no? This is the feature, no? These are some characteristics of waves, no? And I think we identified quite a number of characteristics, no? One of those characteristics is the height of the wave, no? The maximum height of the wave, either going up or going down, which we call as amplitude, no? We have wave frequency, we have wavelength, no? We define a wavelength to be 2 points, no, that are in phase. So these are points that move together, no? So if you see 2 points in a wave that simultaneously move together but in a different, no, position or location, then that constitute a length, no, that we consider as lambda or wavelength, no? So our symbol for wavelength is the one that looks like an inverted Y, no? Now frequency is our number of waves, no, that is created in a unit of time, usually in seconds, no? So for example, in 1 second, no, there are 200 waves created, no, or 20 waves created. Then we will have 20 waves per second or 20 cycles per second, no, which we usually call as 20 hertz. No? Now, I mentioned specifically 20 hertz because 20 hertz up to 20,000 hertz, no, is our audible frequency for sound. No? So that's a unique range of value that when they vibrate, no, with that kind of frequency, we are able to hear, no, that frequency. No? So that's an audible frequency. No? Again, no, if you increase that frequency beyond 20,000, then maybe, no, that's not anymore detectable by our eardrum or ear. No? Or below 20 hertz, no, maybe we are not able to perceive that as well in our ear. No? Now, in the animal kingdom, it's possible that this range of frequencies that go beyond 20,000 or below 20 hertz, no, is still, no, the animals can still sense it, no, but not human beings. No? One example or one phenomenon that we will observe is that before a very strong earthquake, no, let's say a very destructive earthquake will happen, no, I think, no, there's a prelude to that, no, that some rocks, no, underneath the earth is already vibrating, no, but we cannot sense it. No? But you'll notice that some animals on the ground, no, will tend to get out of the ground, no, because they detect that. No? There are animals that will run crazy, no, and you will not understand why they behave that way, no. But actually, no, they are the ones that detect the calamity ahead of time. No? Some birds will fly, no, malulupad na sila, no, in some directions, flying away, no, from that area where they sense that, no, sense that danger. But I think, no, human beings cannot detect that, no, to some extent. No? So again, no, range of frequencies. No? So there are frequencies again, no, that is simply detectable and not detectable by our human ear. No? So the number of waves is known as frequency, no, number of waves per second. But, no, the time for one single wave to be made is known as its period. No? Now, aside from the period, we also have the wave speed. No? And wave speed, which we indicate with letter V, no, is how fast a wave is moving, no, in some sort of a direction, no? Maybe left to right. No? And again, no, aside from the wave movement, there are also wave particles that are also moving there. Now, again, in summary, now we have this triangle that we are seeing now, no? And this explains, no, what's the relationship of the frequency to the wavelength in terms of the wave speed. No? So the value at the top, no, indicates that the wave speed is the product of the wavelength times the frequency. No? Or our frequency can be the ratio, no, or that's the number of waves, no, per unit time. No? So usually we indicate F with, no, F, small letter F, no, with the number of waves. No? Actually, it's the number of waves, no, not wavelength actually. No? So it's the number of waves per unit time. No? So this is cycles per second ang frequency. No? Kindly, you can remove there the word length there. So that's actually the number of waves. No? We are going to go to number one, no? Item number one here, and try to answer it. No? So the question is, no, a wave has a frequency of 10 hertz and a wavelength of 30 meters. No? Question, what is its speed? No? For our number one again, no? The given, no? Based on what is stated, we have F or frequency, 10 hertz. No? Again, 10 hertz is 10 cycles, 10 vibrations per second, no? Or Hz. No? And then wavelength is 30 meters. No? So we will find the wave speed. No? And for our solution, so what will be the equation that we will have for V? No? So our equation is, no, in solving for V or wave speed, lambda or wavelength, no, times frequency, and we will now substitute the value. So that's equals to 30 meters. And we multiply that with 10 hertz. No? Now we will see here that we have two units, meter and hertz. No? So what will be the final outcome? We know that the answer there must be 300. But the question is, what will be our unit? No?
Per second, sir.
Our answer, no, is meter per second. So but ideally, no, we realized that hertz therefore is simply, no, some kind of a unitless unit, no, per second lang na siya, no? So ideally, if you have your meter, no, and it's multiplied to cycles, no, per second, no? So we don't write anymore the cycles per second or hertz, no? We simply copy this per second value, and therefore we end up with meter per second as an answer. No? Okay, do you have a question? Okay, we will try number two. No? So what is our given for number two? No? So for number two, again, I think we will just copy some numbers. So for our number two, here are our given values again. No? So if we read number two question, if the frequency in question number one were changed, no, from 10 hertz to 20 hertz, no? So meaning nagdako ang iya frequency, no? What would be the wavelength? No? So most likely we still need the value of the speed there, no? And the speed will still be considered at 300 meters per second that we calculated. So now we will determine the wavelength, no? So what will be our wavelength? Okay, so in calculating here, no, we will have, no, V divided by F, no? Because that's the transformation. And I think now we can see it here in this triangle. So if you will solve for wavelength, no, or lambda, then the one above is speed over frequency. No? Now, if we will use the period na value, then what we also learn, no, kung ginhatag ang period instead of frequency, that the relationship of the frequency and the period is 1 over t. No? So reciprocal na sila sa aton nga period t. No? And usually ang period t is indicated by a capital letter. No? Capital letter na sa aton t. No? So muna aton nga symbol siguro. Then it's a ratio thing. No? Ma-divide ka na din. No? Okay, muna, no? And again, no, what will we solve here? So we will have here 300. Our numerator will be 300 meters per second, no? Divided by, no, our frequency, which is now 20 hertz, no? Because we increased the frequency. So I think wavelength is a length, no? So therefore the unit is what? So we will divide that. Therefore, what will be our answer for our wavelength? No? So what will be the unit attached to our wavelength? No? So 300 divided by 20 will give us 15. No? And that's 15 meters. No? So that's our wavelength. No? Now again, this is our number 3 given. No? We have a wave speed that is given in number 3, no, around 346. We are also given a frequency of 55 hertz. No? And what we are looking for here is we will solve for the wavelength. No? So lambda. No? So we will have lambda. Now, what I was talking about now was that if we have a given frequency and we relate the frequency to the wavelength, usually the longer the wavelength, then its frequency usually is lower. Kung lagba ang wavelength yan. If the wavelengths are quite shorter, most likely taas ang frequency sina. So somehow the relationship between frequency and the wavelength. So if that is in a similar wave. So frequency in relation to wavelength commonly. Now how do we solve this? So let's say we'll calculate. So how do we answer the value of the wavelength? So maybe I think we have an equation a while ago that wavelength is equals to V over, that's V over F. We divide speed by we divide the speed by our frequency. And therefore what we will be doing is we divide the value 346, that's meter per second again, with our value 55 hertz. How much is our answer here? So since it's a wavelength again, our unit is what?
Meters, sir.
So we will have a unit of meters. So we will just disregard the seconds there, and the HZ symbol, and end up with a unit in meters. So our answer is, so for our number 3, we have our answer of 6.29 meters when we divide 346 meters per second by 55 hertz. Again, wavelength is a unit of distance. So if it is MKS, then we will have to use meters. Our unit of frequency is hertz. That's cycles per second or vibrations per second or number of waves per second. And our period is a unit of time. So that's number of seconds per one vibration. So period, frequency, wavelength, and wave speed.